So I'm starting the recording from this point. Since this is the first question, it should not make a difference. So on this smooth horizontal surface, remember that the surface here, it's a smooth surface. So there's no friction. This block is initially at rest. When from time t equal to 0 onwards, so from time t equal to 0 onwards, these two forces start acting on it. Now, under the action of the forces, it is observed that the block makes a displacement of 100 meters in 10 seconds. So from that, we have to calculate all this data. So take down the values that are given over here. And you also, in this, you take g, the acceleration due to gravity's magnitude as 10 meters per second square. Adinath, you'll have to try your calculation again, beta. The mass of the block is 5 kg. Maybe you have taken the value of mass wrong in your calculation. Just check once, just check your calculation. Yes, Bhagyashri, correct. Adinath, don't confuse acceleration with net force. Okay, net force is mass into acceleration. Remember. Yeah, normal reaction is correct, beta. Yeah, now it's correct. Correct. Good. This answer is correct, Adinath. So I'll just minimize it so that you can see the individual parts of the question. Yes, Aparna, correct. Both the parts are correct. Yeah, Bhageshi, normal reaction is correct, no? Yes, Adinath, correct for the momentum. So I'm just putting up the answers. Rest of you verify and try to get it correct yourself. So the first part you should be getting. Firstly, you will solve for acceleration. Use the fact that initial velocity is 0. Displacement is equal to 100 meters at t equal to 10 seconds. Use these to get the acceleration. Yeah, and once you found the acceleration, then you use the fact that net force is equal to mass into acceleration. So from that you find out F2. So when you do all this, you will get you should get the acceleration. You should be getting the value of this acceleration as 2 meters per second square. And solving that, you should be able to get the force F2 as 10 newtons in magnitude. Then, of course, you will get the normal reaction separately as equal to the weight. That will be equal to 50 newtons. That is what we get. And then you can see that at t equal to 0 for the second part, the initial momentum was 0. At t equal to 10 seconds, the final momentum will become mass into velocity, which you again calculate from acceleration. So when you do that, you will see that you will get this final momentum as 100 kg meter per second. So then you can see that your net force will be equal to change in momentum upon change in time. So that should be equal to, the time was 10 seconds. So 10 newtons, and that will be equal to the net force. Okay, understood. So this is the set of answers you should be getting. Now try working it out yourself from the equations. I'll put up the equations in just a minute or so. But try to get these answers yourself using the equations. Okay, so let's understand the full solution. The first thing is use the fact that initial velocity is 0, acceleration is constant because the forces acting are constant, but we don't know how much. And the displacement is equal to half at square. Now, given that displacement is equal to 100 meters at t equal to 10 seconds. So use this over here. So substitute this information in this equation. So you will get 100 is equal to half t into 10 square. So you will get the acceleration as 2 meters per second square. So this is basically not Newton's law. This is you're using kinematics. Now since the acceleration is equal to 2 meters per second square, now from second law, Newton's second law, the net force on that body should be equal to mass into acceleration. Now, if you think about the body, what all forces are acting on it? So there is, of course, gravitational force mg, which is acting downwards. And that is equal to 50 newtons magnitude. But that has to be countered by the ground force that is acting. The ground is applying an upward force, which we call normal reaction on the floor. That is that. And then, of course, we are applying a horizontal force F1 like this, which is given to us as 20. But at the same time, there is also an opposite horizontal force F2, which we don't know how much, but we know that it's accelerating in this direction. And now we've got that acceleration as 2 meters per second. And we also know that the mass of the body is 5 kilograms. So with all this data, now you can see here that the net force will become F1 minus F2. And that should be equal to mass into acceleration. So F1 is 20 minus F2, we don't know how much. So that should be equal to 5 kilograms into 2 meters per second. So from this you can see that F2 का magnitude कितना आ जाएगा? 20 minus 10 or 10 newtons. So F2's direction already shown in the diagram. So we don't need to show it direction. We just need to find out the magnitude. That's it. Okay. And of course, in the vertical direction, the vertical axis, the acceleration is 0. There's no component of acceleration along the vertical axis. So the net vertical force should be 0. Because the vertical acceleration is 0. So that means normal reaction and mg should cancel. So the normal reaction acting on it should be equal to the weight, or the normal reaction magnitude should be equal to 50 newtons taking g as 10 downwards, upwards. So normal reaction of 50 newtons is acting upwards, whereas the horizontal force F2 should have a magnitude of 10 newtons. And as you can see from the diagram, it's acting in the direction opposite. So this is the complete solution of the first part. Okay, people, this question is clear so far. Okay, now the second part is nothing really. You have to just calculate the momentum at t equal to 10 seconds. So that momentum is nothing but mass into velocity. So for velocity, you can use at, or you can use that v square is equal to 2as, whichever of the two, right? If you go by this method, it is 2 meters per second square into 10 or 20 meters per second. Or if you go by this, v will become square root of 2 into acceleration, which we found out was 2 meters per second square. The displacement was 100. So this will also be the same. So the velocity is 20 meters per second at t equal to 10 seconds. So, and the mass is 5 kg. So the momentum is equal to 100 kilogram meter per second at t equal to 10 seconds. But you also know that the initial momentum was 0. So that's the second part. Since initial momentum, let's say P naught was 0 at t equal to 0, and the momentum at 10 seconds, let's say, it's 100 meter per second. So at t equal to 10 seconds, the momentum is this. Therefore, from 0 to 10 seconds, that is your time interval is 10 seconds. The change in momentum delta p will be the momentum at 10 seconds minus the initial momentum at 0. So that is 100 kilograms meter per second. So therefore, the net force should be equal to the rate of change of momentum. So it should be change in momentum, which is 100 kg meter per second, divided by the time interval of 10 seconds. So it should be equal to 10 kilogram meter per second square, or that is the same thing as newtons. Kg meters per second square is the same thing as newtons. So you can see that the net force is, and we have already verified that. From second law, we had seen that the net force was F1 minus F2, that was 10 Newton. So that verifies that the net force is in fact equal to the rate of change of momentum, which in this case is equal to 10 newtons. Actually, we should just write this as, let the net force be, just write it as rate of change of momentum. And net force, on the other hand, you can see is F1 minus F2. So finally, you are able to verify that the net force, which is F1 minus F2, as this is identically equal to the rate of change of momentum. So that is your verification of Newton's second. Okay, people, hope this question is clear. I think it is fairly straightforward, the question, right? Okay, Bhumi, to you the first part again. Okay, done with the first part now. Make sure you understand the second part also. Okay, done. Okay, so hope both the parts are clear for this question. Okay, now next we'll look at another type of question like this with the similar concepts, but a little bit more tricky. So be very careful when you're solving this question. Okay. So our next example, we have a situation like this, that on the smooth horizontal surface, frictionless surface, we have kept like a slightly longitudinal kind of plank or slab kind of thing. And on top of this, we have kept a smaller block. So this block is of mass m1, this block is of mass m2, and this surface is also smooth. Okay, so there is no friction between m1 and m2, and there is no friction between m2 and the floor also. So given m1 is equal to 1 kilogram, m2 is equal to 4 kilograms. Now what we start doing is, we start applying a horizontal force. We start pushing this block m2 with the force F2. So a horizontal force F2 starts acting on the block of mass m2. So magnitude of F2 is equal to, let us say, 2 newtons. So again, what we have to do here is, first of all, we have to find all the forces and their magnitudes acting on the block of mass m1 and the second block of mass m2, and then find their accelerations, that is the accelerations of the blocks of mass m1 and m2. So tricky question, people. Be very careful when you're solving this. Try this out, people. Yes, Adinath, your answer is correct. Dhruv, your answer is not correct, beta. Just check your concept again here. There is no friction between M1 and M2. So the hint to you is when you are applying the force F2 on M2, that Planck kind of block will just slide from under M1. Yes, Aparna, it's correct as per taking g as 9.8 meters per second square is correct. Okay. But the acceleration is not correct, beta. Okay, so let's understand what's happening here. So first of all, let us understand what all forces are acting on each of the blocks. Okay, so we explain first separately for each block what is happening. For this one and the lighter one which is on top of it. So I'll just show as if there's some separation, but there's actually no separation. So क्या हो रहा है? I am applying that external force on this. This force is of magnitude 2 newtons. Now this block has its own weight, which is m2g, where m2 is 4 kg. So you can write this as, remember this mass is 4 kg. So this is equal to 4 into 9.8. So that is which we can approximate it as 40, or we can write it as 39.2, or approximately 40 meters. 40 if we take g as the approximate value, 10 meters per second square. That is the weight. And then the ground is applying some upward normal reaction on this. Let's take that as some N2. But what will also happen is that this block is applying a downward force on this. So यहाँ पे there is a downward force acting on this block, and this is applying an equal and opposite upward force on this. So if this is applying a normal reaction N1, this is applying an equal and opposite normal reaction N1 downwards. And of course, this block has its own weight, which is M1g, which was 9.8 or approximately 10 newtons. We take g as 10 meters per second square because M1 was equal to 1 kg. Now notice on this block M1, there is no horizontal force. So M1 पे क्या हो रहा है? There are only two forces acting on that block, on M1. Its weight and the normal reaction that this is applying. So its acceleration will be how much? 0. For the smaller block, this is what is happening. There is no horizontal force acting on it. So its acceleration will be 0. So N1 will be equal to M1g, equal to 10 newtons. Or more precisely 9.8 newtons, or approximately 10 newtons. But acceleration is equal to 0. Acceleration of that block will be 0. And only two forces acting on it, as shown in the diagram. Whereas if you take the longer Planck kind of thing, or the heavier object M2, now on that object, there is all these forces acting. There is its weight, which is 40 newtons approximately. There is normal reaction that the ground is applying, it was N2. And there is the normal reaction that this one is applying, which is 10. And add to all that, there is this horizontal force which is acting, which is 2 newtons. So this is giving this a horizontal acceleration. So for this block, what is happening is that vertical forces balance each other. Because there is no vertical motion. There is no vertical acceleration. So vertical forces अगर balance कर रहे हैं, उसका मतलब क्या हो रहा है? N2 is balancing the sum of N1 plus weight. So that's why N2 is becoming 50 newtons. whereas horizontally the block is accelerated. So that net horizontal force is nothing but F, and that should be equal to its mass into acceleration. So that force of 2 newtons should be equal to its mass of 4 kg multiplied by its acceleration. So it will have a horizontal acceleration of 0.5 or half meters per second square, whereas the other block will have 0 acceleration. Okay, so this is the final conclusion of the question. So on the lower block there are 4 forces acting. So there are 4 forces: N1, N2, F, and weight. So that weight is m2g, that's 40 newtons. N1 is equal to 10 newtons acting on it downwards. Weight is acting downwards. So N2 is 50 newtons and it's acting upwards. And this was a horizontal force of 2 newtons magnitude like this. So from that you can see that the net force acting on it is F, and that is equal to mass into acceleration. From that we have got the acceleration as this. That is the story of the lower block, whereas the story of the upper block is very simple. It's just doing this. Its weight is balanced by the normal reaction. We are not applying any horizontal force on it, so it will remain where it is. So what will happen is the upper block tends to remain at rest, while the lower one slides from underneath. Because no horizontal force is applied to the upper block. Okay, horizontal force is only applied to the lower block. Now in practical everyday life, this might be counterintuitive for you, but remember in practical everyday life, there is always some friction between the two. No, it's not frictionless. Okay. So this was the question. Now, this is the first thing you have to understand. The forces which are acting within the system. Then you come to the lower part, which is the individual blocks. Okay, so this is the system. Okay, and what kind of forces acting. Okay. So you can see that this N1 and this N1, they are an action-reaction pair. This normal reaction N1 and this normal reaction N1, they are an action reaction pair. M1 is applying a certain normal reaction on M2, which is downwards. So M2 is applying an equal and opposite reaction on M1, which is upwards. So first make a note of this diagram. Okay. Then come to the individual blocks analysis of Newton's second law, and you will understand why this thing is happening over here. This thing which, so note this down also carefully. Why the upper block just tends to remain at rest till the lower block is slid from underneath it. Of course, by the time lower wala block slide करके आगे निकल गया, then the upper block will fall. Okay, but that will still take some time because the lower block we are showing is a long kind of block. It has a length. It has a significant length. So the moment we apply the force on the lower block, the upper block will not fall down. Now, first the lower block has to slide and lose contact, and then the upper block will slide down. Will fall down freely because of gravity. So hope this is clear, people. Yes, Dhruv, what you're saying is correct. Okay. So hope you've understood this first diagram. Now come to the lower two diagrams, okay, and understand the application of Newton's second law to this block. Okay, so this is the application of Newton's second law. So this is second law applied to the block M1, whereas lower here is the application of Newton's second law applied to the lower block of mass M2. Okay, so this is done, I hope. Right, now let's look at a variation of this question which will make things a little bit clearer. Okay. So Bhaumik finished writing down this part. Okay. Now see, suppose this situation was completely different, and what was happening was that there is friction between the two blocks. Okay, so same values, same two blocks, but this time the major difference is that there is friction between the two blocks. The upper surface of the lower block is not smooth anymore. अगर ऐसा हो रहा होता, that was the case. Okay. Whereas the floor is still smooth. The floor is still smooth. So this is still a smooth or frictionless surface. But the upper surface, this one now, यहाँ पे suppose this is what we call a rough surface, or there is friction. And once again, this block is M1, this block is M2. And we start pushing this system with a force F. But this time what we observe is that because the surface is rough, this surface is rough, instead of sliding, M1 and M2 move together. There's no slipping between them. So it's like you're applying the force on M2, but because of the friction, M2 is carrying M1 along with it. So what we observe is that, of course, again, given the same things, that M1 is 1 kilogram, M2 is 4 kilograms. Now, it is observed that on application of the force, on application of the horizontal force, F of magnitude 2 newtons, okay, what is happening here is the two blocks move together, okay, such that there is no slipping between them. There is no slipping between them. So again, show all forces acting on blocks M1 and M2 separately and find their accelerations. So in this question, I'll straight away give you a hint. And the hint is the blocks M1 and M2 move together without slipping. Due to friction. Acting between them. And further, what will happen is that you will see that the lower block M2 will apply friction along positive x-axis on M1. And not to forget, M1 will apply equal and opposite, okay, because of Newton's third law, equal and opposite friction on M2. Okay, so this is the hint that I am giving to you to solve the question. Just try this out now, people. So this time the question is telling us that when we apply the horizontal force of 2 newtons, what we observe is that the systems moves together. That is the two blocks M1 and M2. It's not like M1, M2 is sliding from below and M1 is remaining stationary and that M1 will eventually fall. It's the opposite of that. You'll see that there is no slipping or there's no sliding happening between M1 and M2. In fact, they move together. Even though we are applying force only on the lower block literally carries the upper block with it because of the frictional force which is acting between the two of them, because the upper surface is rough. Now, this is more like something you'll be able to relate to in everyday life. Like if you take a carom striker and put a carom coin on top of that, and you apply relatively less amount of force on the carom striker from below, you'll see the striker carries the carom coin with it. If you were to take a carom striker, keep it on that smooth carom board surface. Now on top of this, you keep another coin, which is relatively lighter, and you push this with relatively less amount of force. You'll see that there's a good chance that the two of them will slide together. There won't be any slipping between them. They will slide together. So that kind of situation is happening. Okay, so just try it on the basis of, and try it in the order which I've given. Then you'll be logically able to understand how to solve also. So first of all, make the individual diagrams of M1 and M2 showing all the external forces acting on them. Vertical, horizontal, सब मिला के जो जितने external forces act कर रहे हैं, you show all of them in the individual diagrams of M1 and M2. Then you will understand how to solve this. Adinath, your concept of forces is correct, but just keep one thing in mind that this time there is no slipping between the two blocks. That means उनका relative motion कितना है? Zero है ना? So if their relative motion is zero, they should have common acceleration. They should have the same amount of acceleration. So whatever the acceleration of the upper block, same will be the acceleration of the lower block. So you have to solve the question with that concept in mind. Okay, I hope you are following. Yes, that's correct now. Now your answer is correct, Adinath. Anybody else has solved? What about Aparna, Dhruv, Bhaumik? Anybody else has solved? No, Aparna, same thing I'm telling to you, which I just discussed with Adinath. They will have common acceleration. They will not have different values of acceleration. You're following my point? दोनों का same amount of acceleration होगा. Yes, Aparna correct. Bhageshi correct. Yes, correct. Dhruv. So now you understood. Okay. So what we will see actually, what I was describing earlier, that describing to you earlier, that when I apply this force, because this surface is smooth, but this is sufficiently rough, whereas this one is smooth. So what I'll see is that the moment I start applying this force like this, moment I apply this horizontal force F on this, the whole system starts accelerating with a common acceleration. They start moving together as one object would move with an acceleration E. And this acceleration we want to find out. Okay, so this is the meaning of there is no slipping. Okay, so since it is observed that there is no slipping or what we can call sliding between the two blocks M1 and M2. So that implies that their acceleration must be identical. So that is why what will happen is, because the acceleration is identical, at some time t, both of them will have common value of velocity. This is also moving with the same velocity as this is moving, because this is not shifted with respect to this. That is the meaning. There is no relative motion between them. That is what will happen here. So if they were starting from rest at t equal to 0, both the blocks were starting literally at rest at t equal to 0. So by the time it is some time t, what will happen is that both of them should have moved exactly in the same way, and both of them should be moving with the same velocity. That is the meaning of there is no slipping between them. So अगर slipping नहीं हो रहा है, that means both of them would have had the common value of velocity at that time, and that velocity v could be equal to et. That is the meaning of no slipping. Their acceleration must be identical, so that there is no relative motion. There is no relative motion between them. This is the meaning of this. So no relative motion between them. That implies that now individually, if we look at it, individually trying to understand each of the blocks, let's figure out what all forces are acting on them. For each of the blocks, where we understand that this block is of mass m2, this block is of mass m1. So now let us analyze the individual forces on each of the blocks. So of course we have the vertical forces. Weight इसका m2g, which is approximately 40 newtons. इसका weight m1g, which is approximately 10 newtons. The floor is pushing this one back upwards with some normal reaction n2. This is pushing this block upwards with some normal reaction n1, and this is pushing this one downwards with some normal reaction. Same magnitude but opposite direction. So vertical forces are same as what we've seen previously. Okay. But the difference is this time horizontal forces may, the moment I apply this force, this will automatically now generate a friction on this one. Because this will, the tendency, the moment you apply this force, this is having a tendency to move like this. This is having a tendency to move towards the right. So this will carry this with it by applying a frictional force on this, on the floor of this block towards the right. And this will apply an equal and opposite friction on this one, which will be towards the left. So this friction and this friction are an action reaction. These two frictions are an action reaction. So what happens here is that M1 applies friction F. Okay. If I take this as my x-axis and this, okay, on M2, or rather M2 applies on M1, the lower block applies a friction on M1, that is the upper block, along positive x-axis. Let's call that the action. That implies that M1 will apply equal in magnitude but opposite in direction. So along negative x-axis on M2, on the lower block. So the upper block will apply an equal and opposite frictional force on the lower block to prevent it from slipping. And this combination of forces will act such that the two blocks slide together. Slide means with respect to the floor, not with respect to each other. Okay. There is no slipping between them. So no slipping between them also means that there is no relative motion. They are moving together. So that means that there's no slipping between them, and they have identical acceleration. They have identical acceleration P. Which we need to find out how much it is. Okay. So both the amount of friction acting and the identical acceleration A we need to find out. So we'll come to that. Now we'll come to solving Newton's second law, but first of all you understand the diagram, understand how the different forces are acting. So you can see on the lower block there is now a total of 5 forces acting. 3 vertical forces, weight, 2 normal reactions, and 2 horizontal forces. Capital F, the external force you are applying, and friction that the upper block is applying on the lower block. And similarly on the upper smaller block now, there are 3 forces acting, 2 vertical forces, normal reaction and weight, but also 1 horizontal force of friction. Okay, now we have to solve this situation so that we understand that both of them are moving with common value of acceleration. So we have already seen, we've written here, so this one is moving with some acceleration A. This will also be moving with the same acceleration. So we'll incorporate that in Newton's second law, individually applied to each block, and from that you can see you'll be easily able to calculate the acceleration, which you have got to be 0.4 meters per second square, and that is the correct answer. The acceleration will be 0.4 or 2 by 5 meters per second square. Okay, so done. Now see, apply the equations over here. So coming to this one, coming to the larger block, you will see your forces. Just talking about the forces just now. So क्या forces है? ये वाला horizontal force है. यहाँ पे friction backwards लग रहा है. यहाँ पे this block is pushing it down with some normal reaction. Its own weight is pushing it down, and the ground is applying some upward normal reaction. So these are the 5 forces which are acting on it. The external force, which we know is equal to how much it was, 2 newtons. This friction, which we don't know right as of now how much it is, then its own weight, which we know is 40 newtons. This normal reaction, okay. So from the other blocks FBD, we know that this is 10 newtons, and therefore this will be 50 newtons. Okay. But we'll see that. We'll get this also by free body diagram. Okay. And this block, under the action of all these forces, has a horizontal acceleration of p. So इसका vertical में क्या होगा? Vertical dimension में forces should balance. So the forces balance, then the upward force N2 should balance N1 plus the weight. Okay. So that is how you will get that this will come out to be 10 newtons, this is 40 newtons. So this will come out to be 50 newtons. But now if you see horizontal forces, now along the horizontal dimension, what is happening? The net force should be equal to its mass into acceleration. So net force कितना हो जाएगा? Capital F minus friction, that is equal to m2 into e. So this is our first useful equation. And if we write this numerically, we can write it like this, that 2 newtons minus some unknown friction is the mass of this block, which is 4 kg multiplied by the acceleration. So you can write it numerically like this. Okay. Now similarly, you understand what is happening to the upper block. So similarly, for the upper block, if you look at individually that upper block situation, what all is happening to it. So you'll see that it's comparatively much simpler. There are only 3 forces acting on it. 2 vertical forces जो balance कर रहे हैं, जो already we have found out weight equals to this normal reaction equals to 10 newtons. So this we already know. But also there is one friction which is acting on it like this. There is this friction acting on it. And that is what is giving it the horizontal acceleration. But mind you, that horizontal acceleration should be same as this one. It should be the same as the horizontal acceleration of the lower block. So इसके लिए क्या हो रहा है? Vertical के along, again forces balance. And we are seeing that N1 balances M1G. So N1 is equal to 10 newtons. Because it was given to us that M1 is equal to 1 kilogram. But what about along the horizontal direction? Now along the horizontal direction, for this one now the net force should become its mass into its acceleration. Okay. So the net force कितना होगा? वो सिर्फ friction होगा यहाँ पे. So the net force is friction, and that should be equal to M1. So this is our second equation. This is our important equation here. Or substitute this, so it will become E in magnitude, because M1 was equal to 1 kg. So now that we have got our 2 equations, we are in a position to solve them and find out the 2 unknowns. What are the unknown quantities for us? Friction and acceleration. So we have equations 1 and 2. So you can see that from above, equation 1 is that F minus friction was equal to M2A, or numerically that was becoming 2 minus F is equal to 4. And our second equation just now, that is this. So friction should be equal to E. Now solve these two to find, first of all, the acceleration A, how much that is, and then also to find out how much friction is active. So this will become the complete solution. You're understanding this, people? So this is how you'll solve this. So this diagram, now you individually analyze for each of the blocks. Okay, so individually apply Newton's second law for each block. So the first one is giving the lower block, I've done it, you can say, in reverse order, but it's not important which order you solve it. And similarly here, the upper blocks. So just make a note of these two equations and then solve them. Okay, so people, hope you understood equation 1 and 2. And now in the process of solving, equation 2 will come from the lower block, which is much easier as I told you. So again, showing it to you for your reference. And the final step I left for you to work out. Okay. I'll show you the steps, but when you solve equation 1 and 2, you should be able to get the acceleration. The common value of A will come out to be 0.4 or 2 by 5 meters per second square. So solve the final two equations and you should be able to show that the acceleration will come out to be 0.4 meters per second square. Yes. So acceleration will come out to be 0.4 meters per second square, and friction will come out to be 0.4, but its unit will be kilogram meter per second square. So when you solve this, you will see, just add the two equations. So equation 1 plus 2 per 2. So you will get 2 is equal to 4 plus 1e. So you will get the acceleration as 0.4 meters per second square. Now substitute this in equation 2. So friction is equal to m1e. So it is 1 kilogram multiplied with 0.4 meters per second square. So the friction, which is a force, will have a magnitude of 0.4 newtons. Okay, so they'll have the same numerical value, but remember they will have different units, because friction is force and acceleration is rate of change of velocity. So this is another critical aspect of this thing, Newton's laws of motion. Alright people, so hope you've understood these questions, and with this we come to an end of today's lecture. Now I'll just tell you some questions which you can work out during this week from your module exercises. Okay. Just write down the questions here so that you remember also. Just give me a moment. So if you just turn to your physics 1 booklet, and in that your Newton's laws chapter, which is around page 37 if I'm not mistaken. Sorry, page 27. Page 32. Okay, so your force and laws of motion chapter starts on page 32. So laws of motion section 2 of physics 1 module, page 32 onwards. So in that you can go through the theory portion. So the reading of sections 2.1, 2.2. So basically 2.1 onwards, you do reading up to 2.9. Then 2.10 onwards is friction data, so we'll discuss at a later stage. So we'll come back to that later. Then from exercise 1, questions you can try out. So from exercise number 1, into questions 1 to 12, try them out. Then exercise 2, do questions 1, 3, 4, 6, 7, 11, 12, 14, 15. Try out these questions. And then from exercise 3, do section A, 1, 2, 3, all 3 questions. And from section B, do questions 1. So this is something you can work out yourself as a home assignment for this week. All right, people. So that's it from my end. Please make sure you try out these questions and read this part from the theory notes also. And that's it. Thanks for attending and stay safe and all the best.